Dear students, welcome to my channel designed for conceptual summation to begin to be now what you will be hereafter. Euclid division algorithm is a step-by-step procedure of Euclid division lemma between two positive integers. It is mainly useful to find out the HCF of some numbers which are generally difficult by other simple factorization methods. We should that you are given two numbers a and b, then you have to take the bigger number as the dividend and smaller number as the divisor. The question q and remainder r are found according to Euclid's division lemma. So if r is equal to 0, then this b will give the HCF of ab. But if r is not equal to 0, then you go to the next step, taking this b as the dividend of the next step and this remainder of the first step as the divisor of the second step. And then as before, you find out q1 and r1. Now if r1 is equal to 0, then this r will be the, okay, that means this r here, divisor of this step, r is equal to HCF of AB. HCF of AB. But if you find that this R1 is not equal to 0, then R1 is not equal to 0, then go to the next step. R is equal to R1 Q2 plus R2 as above. Okay. Now if R2 is equal to 0, then this R1, which is the divisor of this step, will be the HCF of the given numbers a and b. If R2 is not equal to 0, then go to the step, this R1 as the dividend of the next step and this R2, which is the remainder of this step, it should be the divisor of the next step. Then find the integers q3 and remainder r3. And same way you justify here, if r3 is 0, then this r2 will be the HCF of these two. Otherwise, proceed as above to get the required HCF of AB is equal to Rn. For the step where the remainder is 0 will be the. Now let us come to a practical problem taken from the exercise 1.1. Find the HCF of 196 and 38,220 using Euclid's division algorithm. See this one. Applying Euclid's division algorithm to the given numbers, we have 38,220 equal to 196 into 195 plus 0. How it is? Because mentally you cannot calculate, so you take the help sidewise. Okay, for your rough calculation, divide this number by 196. We see that this by division procedure we are getting like that. Ultimately it is 0. Okay, this is the step of 0 remainder, so that the corresponding divisor is the HCF. See, 0 it is available, so corresponding divisor is 196, so this is the HCF. Thus HCF of 196 and 38,220 is equal to 196. This is the solution. Okay, let us take another exemplar problem, important exemplar. Show that the numbers 350, 477 and 849 are co-prime. That means you have to show that the numbers are having only one as their HCF. We know that whenever some numbers have their HCF only one, they are mutually called co-prime. Okay. So in such a case of multiple numbers, any two numbers you can select, and out of these two numbers you have to take the bigger one as the dividend and the smaller one as the divisor of the first step in Euclid division lemma. Okay, So likewise, we are taking these two numbers, 447 equal to 477 equal to 350, and it is one time only available into 1. Okay, then keep a plus sign and then put this difference here, 127 it is, okay, because the rightmost number, the rightmost integer of this number minus the rightmost integer of this number equal to 7, and like that 7 minus 5 equal to 2, and 4 minus 3 equal to 1. So you need not calculate it on the right side. Unnecessarily, don't waste your time and do not be confused. But in the next step, since remainder is not 0, it is 127. So we are going to the next step, taking this divisor as the dividend and this remainder as the divisor of the next step. So you write 350 equal to 127 and multiplied by how many, 2 or 3? If you cannot understand, then you take the help of rough work here. 350 divided by 127, it is 2 times only, okay, giving, and then remaining 96 here. So you come here, put it into 2 plus 96. Still 96 is not 0. Okay, so in this step, 127 equal to this 96 is going to be the divisor, and obviously this 96 is one time available, so into 1 and then keep plus sign and then subtract this division. Okay, or if you feel difficulty still, then this 96 is there, so divide this by this remaining 31. Okay, because in this step 31, so you are getting 3 times and remainder is 3, so you write like this 31 into 3 plus 3. So still we are not getting 0 here. So this 31 will be the dividend and this remainder 3 will be the divisor of the next step. So write 31 equal to 3 into what it will be, a little consideration, so that it is 10 only. Okay, and remainder is 1. Do not go there to calculate further. It is very easily understood from here. Still 1 is remaining, not 0. So you come here, this 3 will be the dividend and equal to this remainder 1 is the this one is the divisor. So 3 is equal to 1 into 3. If we multiply it by 3, it is giving 3. So remaining nothing but 0 plus 0. So this is the step where attaining the HCF. Okay. Therefore, HCF of 350 and 477 equal to 1. Now the question is that there are given 3 numbers. Same thing, Euclid division algorithm is applied between any 2 numbers only. But whenever more than 2 numbers are given, then what we do is we take the HCF of the first 2 numbers and connect it to the remaining number for Euclid's division algorithm. So we write again, by Euclid division algorithm between this HCF1 and remaining number 849, we get 849 equal to, obviously, because this is the number and here divisor is 1, so by which we can multiply to get it, it is obviously 849. Okay, then nothing remaining is plus 0, so very easily it is giving 1 as the HCF of this 1 and this remaining number 849. That means this step HCF is giving the HCF of all the given numbers. Okay, and similar is the case of more than 3 numbers, 4 5. Okay, 4 5 numbers, etc. Anyway, for this problem actually HCF of this equal to 1 implies HCF of 350, 477 and 849 equal to 1. Okay, since 1 is coming as the common factor between all of them, then you can conclude, hence the numbers 350, 477 and 849 are co-prime. This is the answer. Okay, now this question can be in this way also, show that the numbers 350, 477 and 849 are co-prime with the help of Euclid's division algorithm. Okay, okay. So when mentioning that Euclid division algorithm, you must do by taking Euclid's division algorithm. Otherwise, not mentioning mean you have to consider your own judgment. Okay, which way you can proceed, by general factorization or Euclid's division algorithm. So in such a case, better it is to be done by Euclid's division algorithm only. I hope that you have understood the problem. Okay, please do practice well the problems so that you can develop the ability to more solutions of such problems. Thank you.